Okay, before we get into dividing and multiplying rational expressions, we got to talk about how to simplify them first, because that's going to come in handy later on in this unit. So simplifying rational expressions. Reminder, rational expression is just an expression made up of two expressions divided by each other. So they look like fractions. So this first one is just 16 over 65. It's just a rational expression involving just numbers, and we want to simplify it. Well, to simplify it, we want to see what factors or what parts make up 15 and what factors or what parts make up 65 and cancel out what we can. So I'm going to do a little bit of scratch work over here on the right, and I'm going to break down 15 into its parts, or I'm going to factor 15, and that factors into 3 and 5. And then I'm going to also factor 65. So 65 factors into, let's see, if I divide that by 5, that gives me 5 times 13. Okay, so 15 over 65 could be written as 3 times 5 divided by 5 times 13. And since everything is being multiplied on both the top and the bottom, that makes it okay for me to cancel out the 5's. The 5's cancel out, and this can be rewritten as 3 over 13. So in order to simplify a rational expression, you factor it as far as you can and cancel out everything that you can. So that one simplifies to 3 over 13. Let's try this next one. This next one is made up of variables and also numbers. So we want to try and break down the numbers and also cancel out whatever variables we can. So if I look at the numbers first, I notice that 3 is as factored as it possibly can be, and so is x cubed. I can't break up x cubed any further. 6, though, I can rewrite as 2 times 3, and I'll leave the y and the x to the fourth alone. So then I see pretty quickly that I can cancel out a 3 from the top and the bottom. I'm looking for other things that I can cancel out. It looks like I only have one y on the bottom, so I'm not going to be able to cancel that at all. I only have 1, 2 on the bottom. There's no more numbers on top. I can't cancel that at all either. Last thing that I can cancel, though, is I've got 3 x's on top and 4 x's on the bottom. So all 3 of them will cancel out on top, and if I take 3 from the top and 3 from the bottom, there will only be 1 left on the bottom. So when everything shakes out, I get on the bottom 2y x, because I canceled out the 4 and there was 1 left. And on top, if I cancel out everything from the top, that means that there's not a 0 up there, but a 1. So that's how I can write that in its most simplified form, is 1 over 2yx. All right, let's go on to the next example. Okay, still simplifying. Now this one is already in its factored form. Notice that I can't break up 4 I can break up 4 into 2 times 2, but there's no number on the bottom, so there'd be no reason for me to break up 4. But if I look at the things in parentheses, x plus 3, I can't break that up any further. I can't factor that at all. So same with the bottom. Everything is completely factored. Once it's factored, in other words, there's a bunch of terms being multiplied together on the top and the bottom, then I can start canceling things out. And I notice that I've got an x plus 3 on top and an x plus 3 on the bottom. Those will cancel each other out because x plus 3 over x plus 3 is 1. So all of that cancels out, and I'm left with just 4 over x minus 5. And that's it. That's as simple as I can get it. Let's do one more. All right, simplifying rational expressions. The last example. Now this one I've got a factor. Okay, the top and the bottom are not completely factored. So I'm going to have to go and factor it. So they're trinomials, or the top one is a trinomial, and I'm going to have to factor it into, it looks like x is my leading terms, and then it's got to be numbers that multiply to give me 15 and combine to give me negative 2. So I've got numbers that multiply to give me 15 are 5, and 3, and I think that's it. So it's got to be 5 and 3. And they have to combine to give me a negative 2. So I think if I have a negative 5 plus a 3, that gives me negative 2. So it's got to be negative 5 plus 3 here on top. So that's completely factored. And then on the bottom, I got this x squared minus 9. Well, this is just kind of a rule that you might want to kind of remember, but since both x squared and 9 are perfect cubes, or perfect squares, I can break this into x minus 3 times x plus 3. So on the bottom, I'll write x plus 3, now we'll stick with minus, x minus 3 times x plus 3. And now both the top and bottom are completely factored, so let's get rid of all the stuff we've got written around here. Both the top and bottom are completely factored, so now I can start canceling things out. And I see that I've got an x plus 3 on top and an x plus 3 on the bottom, so I can cancel that stuff out and leave the x minus 5 divided by the x minus 3. Caution right here. You cannot cancel out the x's. This is your final answer. Okay? And the reason is that since x and 5 on top are being subtracted and x minus 3 on the bottom are being subtracted also, I can't cancel those out. If they were being multiplied, cancel away. But since it's not multiplication, that's kind of connecting those two terms, the x and the 5, I cannot cancel out the x's. So I have to just leave it as x minus 5 divided by x minus 3. And that's how you simplify rational expressions.